Paying your sewer bill helps keep our Great Lake great, but paying that bill can sometimes be difficult. That's why the Northeast Ohio Regional Sewer District has expanded its cost-saving programs to help customers lower their bills. To see if you qualify, call 216-881-8247 or visit neorsd.org/save. Your sewer district, keeping our Great Lake great.
The Northeast Ohio Regional Sewer District presents Clean Water Works, a monthly news magazine and your source for local water, sewer, and stormwater news that affects you and your community. Clean Water Works features the people, projects, and programs that are protecting your health and environment. Your sewer district, keeping our Great Lake great.
Welcome to Clean Water Works. I'm Ray.
And I'm Jen. We're out here today at the Westerly Wastewater Treatment Center. In today's episode, we'll learn how the sewer district monitors water quality in area streams.
We will also take a look at a stormwater and inspection maintenance project.
But first, we'll go to Sewer U, where Frank Greenland discusses green and gray infrastructure, as well as the difference between combined and separate sewer systems.
Hello everyone and welcome to Sewer U, Sewer University. We're going to talk today about the history of sewers and clean water in Northeast Ohio, specifically the greater Cleveland area. I am Frank Greenland. I'm the Director of Watershed Programs. This presentation is available on our website at neorsd.org/seweru.
I had a question regarding what the district uses as its funding streams for the investment. Is it state funds, local funds, federal funding streams?
Okay, that's a good question. Now we use user fees. You fund our program primarily. So we have user fees. All of our customers pay a regional wastewater bill, and that's a primary source of funding. Back after the creation of the Clean Water Act in '72, there was a federal construction grants program. Initially, it was 75% federal, 25% local, and then later in the 80s, it switched to 55-45. And the district was a huge player in that market. So between federal construction grants and some federal appropriations for good projects, $650 million of federal investment came in, and that helps offset rates and rate increases. So we were an active player, and we really seized a lot of that federal construction grants, which was good for the region and helped us accelerate progress. We've been in the bond market, where we get relatively low interest bonds to support our construction. Now when you get a bond, it's just like a mortgage. You got to pay back. There's debt service, so you're paying interest payments over time. More recently, we've used state revolving loan funds, state of Ohio, as again a low interest loan, and today the market is right to use that as our primary funding mechanism. And we've gone to the state revolving loan fund. We don't see grants on the horizon. Could happen. We're always looking for it, but today it's really low interest state revolving loans and user charges. This is McKenzie on the breakthrough. This is a big day for the tunneling crews. I think this was 2 or 3 year construction. So 3 miles later, that's the breakthrough of that tunnel. This is what it looks like after the concrete lining gets in place, just to show you how big these tunnels are. Now when they go into operation, the ventilation system on the top and the conveyor system comes out, so you've got full storage, but it's a big swimming pool, just happens to be a couple 100 feet underground. I talked about green infrastructure. We look for big, larger scale opportunities to use green space to either slow down or infiltrate, allow that storm water runoff to soak into the ground, instead of piping it to the combined sewer system. So the premise was if we could get some of that stormwater and keep it out of the system, that would mean less overflow going over those weirs. And so we have a number of sites where the district's constructed green infrastructure. These are challenging at times, but also good from a public standpoint. There are leave-behinds, public parks, and other amenities. So green infrastructure has been employed by the district as well. This is a small-scale green infrastructure. This is the courtyard by Marriott. They sit on a sand layer, locally. There's not a lot of sand, but the glaciers way back in the day pushed some sand in certain areas. And sand is highly permeable, so you can pour a lot of stormwater into it and it will essentially go away. This site was a good demonstration site. They sat on sand, they took all of their parking lot and some rooftop water, and it goes into a sand lens below. Nothing runs off this site to the combined sewer system. So that's a pretty good opportunity, and we took it. Public Square was transformed. There's a lot of green. Public Square didn't look so green prior to this construction. So we partnered with other entities to make sure that if we're going to green up Public Square, let's employ some green infrastructure practices to keep stormwater out of the combined sewer system. So it's another example of how you can use surface amenities to reduce the amount of stormwater that could go into the combined sewer system and result in overflow. All right, that's a lot on combined sewers. So combined sewers, the oldest ones, 1860, I think, is the first one that we know, where they actually started to connect houses to a combined sewer. And 1930 or 40 is when the combined sewers kind of went by the wayside. The region shifted to what's called separate sewer systems. Separate means two pipes. There's still a sanitary sewer to collect sewage from homes and industry, take it to the treatment plant. A separate storm sewer collects the stormwater runoff independently and routes it to the nearest water body. This region, though, there was an evolution on how we left combined sewers and went to separate sewers. And this is fairly unique to the greater Cleveland area. We're not seeing a lot of these anywhere else in the nation. So it's great to be unique, but these are highly problematic. We call them common trench systems. And what they did was, instead of build one pipe, we're going to do the two-pipe system, but we're going to dig in one trench. And I think the reason was cost. We have high rock at certain locations, so it gets very expensive to dig through rock. And they figured, we'll dig one time and put two pipes in the trench. And that's what a common trench sewer is. There's three types in our service area. To the left is a common trench where there's separate manholes. Okay, there's some separation, and you can access the sanitary in one manhole and the storm in another. And that's probably the best of the worst. Common trench systems are very bad. The middle one is one manhole, and that's another weir wall, just like a combined sewer overflow weir wall. They put it between the sanitary and the storm. Now the difference here is these weir walls are pretty high, and so the ability of the sanitary to spill back to the storm and impact water quality in area streams is a little reduced. But you can also overflow the storm into the sanitary, and that could lead to basement flooding. The one to the right is an over-under with a removable plate. That's the storm sewer on top and the sanitary sewer on bottom. One manhole, so there's a plate, and the crews have to remove that plate to be able to clean out the sanitary sewers. Well, these things weigh 70 to 100 pounds. And once the plate goes, sometimes the plate doesn't go back on. And then the next rain, you're going to inundate the sanitary sewer, which could lead to basement flooding, or the sanitary sewer could get in the storm runoff and impact water quality at the area streams. There's the plate. Now there's the plate to the left is almost all the way on. You're in the storm sewer. The brick is the storm sewer. The plate's supposed to be over that sanitary sewer that you're looking down into. And a lot of sometimes 30–40% of the systems, the plate's either misaligned or missing. And so that allows a lot of stormwater and wastewater to go back and forth, which is a real problem. Whenever you build a trench and you have some backfill, say you have some limestone, some rock to keep the trench, well, when it's underground and it rains, or even if it doesn't rain, there's groundwater under the surface. The trench fills with water. And when a trench fills with water, water finds its path of least resistance. And if it's a crack in a pipe, meaning the stormwater will get into the sanitary sewer, then it will happen. And vice versa. If the sanitary sewer is loaded up and there's a crack that allows it to drain itself to the storm sewer, it will do that too. The problem too are these things are 100 years old now, getting to be. Some of these sanitary sewers are bordering on 100 years. Some of them were started to be built in the 20s. So now you have a 100-year-old pipe, and nothing in the ground is going to remain pristine over 100 years. So cracks and leaks in the pipe, and cracks and leaks on private property, people don't understand that the sewer system's not just that sewer in your street. You have a private sewer system in your front lawn that takes the waste and the stormwater from your house to that pipe. And so that's 50% of the system. So it's cracks and leaks. Nobody checks their private lateral unless their basement's flooding. So from a structural integrity standpoint, there's a lot of cracks and leaks. These are 100-year-old pipes, some of them. And it's just a natural occurrence. And unless you do things, invest to line pipes or replace pipes, it's going to get in. And that's why we have a lot of cross-transference of storm and sanitary. The area then moved from the common trench system, which seems to be very unique to Greater Cleveland, to a true separate system, where we built 2 trenches and we separated them, which actually is the best arrangement because you're keeping that storm pipe that's got a lot of storm water away from the sanitary. So 2 separate trenches, and now we have what we call the truly separate system. And these are our newer suburban communities, our separate trench systems. But all of these systems have problems. Some of them emanate right at the home. You can either have your sanitary lateral from your house improperly tied to a storm sewer in the street. It happens. You're like, how does this happen? But it happens because if you're not inspecting and you have plumbers out or contractors out, sometimes the nearest pipe is the best pipe to connect the pipe to. So we see a lot of that. We also see stormwater connections to the sanitary sewer. So your foundation drain or your downspouts are supposed to be connected to a storm sewer, and a lot of times they're not. And they're connected to the sanitary. The sanitary wasn't designed to take that amount of flow. And that's why we have basement flooding. These are what we call illicit discharges. This is the sanitary to the storm sewer. And what we're doing as a regional sewer district is keeping our eye on this. When we see flow in dry weather at the streams from some of these outfalls, we sample it for E. coli. And when we see high E. coli, we go back to figure out what's going on. So that's what we call an illicit connection. And there's more of these than we care to see. We've solved a lot of them. We're always going to be in this game. Some communities have constructed overflows because those sanitary sewers were getting overloaded and the basements were flooding. So they actually constructed overflow devices, weirs, and pipes just like the ones you saw in the combined sewer system. And it was done to protect basement flooding. So that's another problem in a separate sewer system. And these are the pictures, you know, flooded basements, overflowing manholes. When it rains here, we've got issues. So separate sewers, although by design are supposed to be a little less leaky, are still highly problematic. They're old and they take on a lot of storm water. And we have resulting, the worst problem is basement flooding as a result. And you can see the mainline sewer can have cracks and leaks in it. The manholes can have cracks and leaks. The private lateral from your house can have cracks and leaks. Your downspouts can be to the wrong pipe. Your foundation drain can be to the wrong pipe. Your sanitary sewage can be to the wrong pipe. So a number of factors with age as a big contributor lead to more stormwater getting into sanitary sewers, which leads to more basement flooding. That's how that equation works. And you know how the rains have been lately. So we're getting very intense rains, and these sewer systems can't take it. And that's why basements are flooding. Inflow is a direct connection. Like you're in a street and there's that catch basin that allows the street to drain. That's supposed to be connected to a storm sewer. Sometimes they're not. That's a great example of inflow, a concentrated amount of stormwater getting in. Infiltration is a little more insidious. It's underground, small leaks, small cracks, but when you compound it with thousands of miles of pipe, it in the aggregate can be a big contributor to stormwater. So to wrap it up, in the service area, there were no sewers initially. Then we built combined sewers to take waste right to the stream. Then we started connecting house connections to combined sewers and took that to the stream. Then we built treatment plants, and then we evolved into common trench and now separate trench systems. So that's how sewers in the district service area evolved. This graphic gives you some indication of the types, and it's kind of interesting. The tan are the combined sewer areas. So those are the oldest ones. The common trench are in blue. Those were the next generation of sewers. So you can see they're very close proximity to the combined sewer system. And then we moved out and built newer sewers that were purely separate. But some of the oldest separate sewer areas were either constructed poorly or because of their age are taking on a lot of stormwater, so they start to act like a combined sewer. The green areas are served by relatively newer separate sewers that are pretty tight. They're not taking on quite as much water. And the pink areas are the areas that are still served by septic tanks. So there's no sewer. That's home treatment, home sewage treatment. To give you perspective, and these numbers are growing, but the district, the interceptor network and the tunnels we've built, we own, operate, maintain over 300 miles of pipe, regional pipe. The communities own, operate, maintain 10 times that. They own all the local sewers in the streets, and the right-hand graphic shows you those. And that's just the mile of sanitary or combined sewer local in the street. So when you add in the local, your house connection, that's times 2. So now you're at 6,000. And we didn't even add in the storm sewers and the storm sewer laterals. So now you're 12,000. That's a lot of pipe. That's under local responsibility. So in terms of the Clean Water Act and making sure we're protecting the streams, we certainly have the combined sewer overflow issue and the treatment plant issue, but there are local Clean Water Act obligations at the local level, SSOs and common trench issues, things like that. But I wanted to give you a depiction of the regional versus local perspective, and these systems have to work together to make sure we're making sound environmental progress. So going forward with the nature of the rains and how things are changing and we're getting these 100-year storms, like all the time, it's going to be a big deal going forward. We have old 100-year sewers, and we have some pretty spiky rainfalls. So we're seeing basement flooding spikes. And it's a major investment to retool a system. So how we're going to deal with this situation and that level of service and the level of investment that's going to be necessary to curb basement flooding and other sewer-related issues is going to be a big issue going forward. That's Sewer University.
On August 21st, 2013, the sewer district's 27-foot wide tunnel boring machine completed a 3-mile-long excavation of the Euclid Creek Tunnel. This was the first of 7 tunnels being constructed under Project Clean Lake, the sewer district's $3 billion 25-year plan to drastically reduce sewer overflows into the environment. The 1,500-ton tunnel boring machine, nicknamed Mackenzie, spent more than a year 200 feet underground Cleveland and Lake Erie. The cutter head itself had 52 cutting discs made of tungsten carbide steel, each weighing 260 pounds. The Euclid Creek Tunnel was completed ahead of schedule and under budget and will hold 60 million gallons of sewage and stormwater, reducing pollution entering Lake Erie. In 2017, Mackenzie embarked on another journey with the Dugway Storage Tunnel. This tunnel will capture more than 370 million gallons when it goes online in 2019. These tunnel projects directly impact water quality in Lake Erie by capturing combined sewer overflow that otherwise would discharge to our waterways. That's a Clean Water Works moment in history.
Today we're here with Bruce Hogawalt at the Westerly Wastewater Treatment Center. Bruce is an integrated process manager. And Bruce, can you tell us what goes on here at the plant and specifically in this building?
Yeah, Ray. Here at Westerly Wastewater Treatment Center, our average daily flow is typically 18 million gallons a day. In this building itself is our ferric chemical handling building, and ferric is used to remove phosphorus in wastewater before it is discharged to Lake Erie.
Well, thank you very much, Bruce. Now we will visit with our stormwater inspection and maintenance team to see how they keep our local waterways free of debris.
Right now we're standing on top of the Earthen Dam, and it's a basin that was originally created by the city of Cleveland. It holds the storm water that comes from Mill Creek upstream, and it drains 4 square miles. And we have dredged the basin. There's approximately 12,000 cubic yards came out. The purpose for this basin is to hold back the heavy flows and to allow the sediment to filter out. And so it does require periodic cleaning. Unfortunately, that had not been done since it was created. There was, at the deepest, 9 feet of sediment in this basin. Last Friday, this pool was actually full. It probably had 5 feet of water in it. There's a 24-inch pipe that drains it. Unfortunately, it's been clogged for quite some time. We had a jet truck out here that jetted that out, which allowed the water to pass through to drain into the main basin. And right now we're excavating the sediment that has been accumulating here for many years. With the design of the basin, it will only drain so fast, and so it pools, and that's what causes the water to rise. So it restricts the volume flowing downstream. That's the purpose of the dam, so that it reduces the flooding downstream.
I love my dog, and she loves to play outside. When we're in the yard or taking walks, she poops. No, not in the toilet. On the grass. That's what dogs do. But we remember to pick it up so the yucky germs stay out of the water.
When it rains, water flows right back to our rivers and streams. Picking up after your pet helps keep our water clean. Learn more at wheredoesitgo.org/pup.
Dogs can't flush. Remember to pup.
In our daily lives, we use many products that contain chemicals that may be hazardous to the environment. Many hazardous household products can enter our Lake Erie watershed through improper disposal or even normal use. When these products are rinsed down a drain inside your home, they travel through the sewers to one of the sewer district's 3 wastewater treatment plants. Although the plants provide a high level of treatment to the wastewater that they receive, the treatment process is not designed to remove all of the substances in these hazardous products. In addition, many storm sewers flow directly to local waterways, and if these products are rinsed down outside drains or street sewers, they can harm aquatic life. You can help by making sure these toxic substances are used sparingly and cleaned up and disposed of properly. Take advantage of the household hazardous waste collections offered throughout Northeast Ohio. Residents can use these events to dispose of unwanted oil-based paints, pesticides, and other hazardous substances. To request an informational brochure on this topic, contact our customer service department at 216-881-8247 or visit neorsd.org.
Hi, I'm here today with Kelsey Amidon. She's an investigator in our Water Quality and Industrial Surveillance Group. Welcome, Kelsey.
Thank you, Jen.
So a lot of people might not know that we have an Industrial Surveillance and Water Quality Department. So can you tell me a little bit about what your team does?
I work in our Environmental Assessment Group. So we go out to the streams within our service area and do assessments to see if the water quality is doing good or poor within the area. So we assess upstream and downstream of our wastewater treatment plants, as well as some of our CSOs, and to look and see if any of our projects that we've implemented and to see if those are having a positive impact in the environment.
So how are some of the ways that when you're out in the field you can tell what the conditions of the water are?
So we use 4 different areas to look at when we're looking at a site that we've picked. So we look at the habitat, we look at the water chemistry, we look at the fish populations and the benthic macroinvertebrate populations in a stream.
And that's a fancy word for bugs, right?
Yeah, yes,
that's a fancy word for bugs. So when you're looking at the water chemistry, what are some of the things that you're testing for?
So we'll typically go out, we grab bottles of sample with us and we take it back to our lab to analyze for things such as turbidity, E. coli. We'll look at metals and nutrients within the water. We also take out our data sons with us, and we can get in-stream live measurements of things like pH, temperature, conductivity, dissolved oxygen.
So you obviously track everything, and do you see progress year over year, or is water quality getting better, worse, or does it really just depend on the year?
It does depend on the year and what site we're at. We're not at every site every single year. Over time, since we've started this program, we've definitely seen mostly positive increases in the water quality in the area.
And then you also mentioned fish. So when you're out looking at the different fish populations, what are some of the ways that you track those?
So we use a method called electro fishing to collect these fish. And after we've collected this fish, we sort them by species, and then we'll count and weigh them. And based on what species are there can tell us a lot about the water quality. So there's some species of fish that can live in really polluted waters and just about anything. And there's some species of fish that can only live in really clean, pristine waters.
So what are some of the types of fish that can live in pretty much anywhere, regardless of the conditions?
We'll find things like common carp, some of the catfish species, and then you can kind of get into things like white suckers, where it needs to be a little cleaner, but not necessarily the cleanest and most pristine waters.
So what are some of the fish that you find in the cleanest and most pristine waters? Are there certain fish that your team gets really excited when you find them out in the fields?
Yeah, we get really excited when we find mimic shiners, which are really intolerant to pollution. Sometimes when we find darters. Darters are personally my favorite type of fish. They tend to live on the bottom and dart around on the substrate.
Hence the name.
Yeah.
And those are all little fish. So
correct.
I see you've got some of them here.
Yep. Yeah, so we have a rainbow darter and log perch darters. There's other types of darters that live in Ohio streams. Rainbow darters, sometimes you see photos of. They have these really bright green and orange colors, especially the males during the breeding seasons.
And then what are some of the ways that you help track the macro population?
So for macroinvertebrates, you can't go out and quite collect them the same way you would as a fish. So we have two different methods that we use to collect macroinvertebrates. The first method is we use this over here. It's called a Hester dendy. So we'll take 5 of these and we strap it onto a cinder block. We then bury that cinder block in the substrate in a stream, and then the water will flow over. We'll leave it there for 6 weeks. When we come back in 6 weeks, all the macroinvertebrates that are normally living in the substrate and on the rocks will have gone into all the little crevices that are in there, and they love it in there. It's like a little hotel. They like to stay there. So we'll take it back out of the stream and then look and see what species are living there and how many of them are under there. And then we also go out, when we collect the HD, we'll also do a qualitative sample where we take a net, put it downstream of you and disturb the substrate, and any macroinvertebrates that might be living on the rocks kind of get dislodged, and we'll go in your net and we'll pick them out by hand to see what's living there.
My goodness, so it definitely sounds like a lot of work.
Yeah.
What if someone's interested in this type of work, some of our students that might be watching, what are some of the fields that they should study or they should learn more about to get into this work?
So most of us have bachelor's degrees, a lot of us in biology or environmental science. And we do have an internship program, and a lot of people get experience that way.
Great, wonderful. Well, thank you so much for joining us today, Kelsey.
Yeah.
Thank you for joining us today at the Westerly Wastewater Treatment Center.
We hope you've enjoyed this month's issue of Clean Water Works, and we'll see you next month.